Welcome, class. I know I have been gone for so long. Well, I was suffering from coronavirus, and fortunately, I recovered from that dreadful disease. So now let's get back to work. I was discussing about techniques of polymerization. I've already discussed bulk polymerization, but now I will discuss solution polymerization. This is quite interesting. In solution polymerization, this is on page number 53 in the new book and page number I think so 72 in the old book. So whichever book you have, just go to the page number and see solution polymerization. In solution polymerization, the monomer is dissolved in a suitable inert solvent. So you see it is a solution. What is a solution? Solute plus solvent is solution. So here in this case the solvent is inert where the monomer is being dissolved along with chain transfer agent whenever used. The free radical initiator is also dissolved in the solvent medium, while ionic and coordination catalyst can either be dissolved or suspended. So everything is dissolved in solution polymerization except this ionic and coordination catalyst, which can either be dissolved or suspended. The presence of inert solvent medium helps to control viscosity, increase and promote a proper heat transfer. So there was a problem of viscosity increase in bulk polymerization as we have seen, but in this case of solution polymerization, since a solvent is there which is inert, so it helps to control the viscosity increase. So the viscosity is not an issue in this solution polymerization, and because of that inert solvent there is also proper heat distribution and heat transfer. But there is some disadvantage. The major disadvantage of solution polymerization technique is that however inert the selected solvent may be, chain transfer to solvent cannot be completely ruled out. Hence it is difficult to get a very high molecular weight products. The polymer form will also have to be isolated from the solution either by evaporation of the solvent or by precipitation in a non-solvent. So you see the major disadvantages, like you may be selecting a very inert solvent, but still there is some part of it which will react with the chain transfer agent and which will lead to termination, and you will get a product which does not have a high molecular weight. And then finally when the product is formed, you have to separate it from the solution. You can do it by evaporation or by using a suitable non-solvent. You know what is a non-solvent? Whenever there is a solution, solute plus solvent, and then you add a non-solvent. So what does the non-solvent do? The non-solvent precipitates the solute and then you can separate it out. So it is quite complicated as a process, but if you just keep in mind that non-solvent is something which is used for isolation of product, then you can get an understanding of that. So either by evaporation of the solvent or by precipitation in a non-solvent, and removal of the final traces is always extremely difficult. So no matter how hard you separate out the product, it is always difficult to completely separate it. Some fine traces will be there. Solution polymerization technique nevertheless can advantageously be used where the polymer is used in the solution form. Suppose you are using the polymer in the solution form itself, then this solution polymerization technique is very useful. For example, polyvinyl alcohol, it is a polymer which is in the solution form. As in the case of certain adhesives and coating compositions, or in systems where polymer formed is insoluble in its monomer or solvent and precipitate out as slurry and is amenable for easy isolation. So these are some of the systems where solution polymerization is used. Coming to the practical application, industrial production of polyacrylonitrile by free radical polymerization, PAN, polyacrylonitrile by free radical polymerization, and that of polyisobutylene by cationic polymerization use the solution technique. So here are the two examples: industrial production of PAN by free radical polymerization and that of polyisobutylene by cationic polymerization is used solution technique. Block copolymers are also made exclusively by this techniques. So block copolymers are also made by this technique. So for a better understanding, let's watch a video of solution polymerization.
Now we discuss solution polymerization. This is the thermostat. Beaker is kept on the thermostat. Now we are adding the monomers which are already dissolved in the suitable solvent. Then we are mixing a initiator and a chain transfer reagent. The whole mixture is kept under constant agitation. Now we can see how the initiation and propagation is taking place. After propagation, termination occurs. During the termination, polymer is produced. The polymer is dissolved in the monomer, so we are adding a suitable non-solvent. The polymer will be precipitated out. This polymer can be separated from the solution. This is the scheme of the solution polymerization reaction. Now we see the advantages of solution polymerization. Here the heat control is easy. Viscosity buildup is negligible. Next we see disadvantages. It is difficult to get very high molecular weight polymer. The polymerization requires solvent recovery and recycling. Next we see applications. In the solution form, it can be directly used as adhesives and coatings. In the next video, we will discuss suspension polymerization. Thank you.
Yeah, so don't compare it exact word to word from the literature given in the book and this video. This is just for your understanding. Okay, stop.